Good day, everyone. Today we are talking about section 8.3, completing the square. So our targets for today, I can find the value to make a perfect square trinomial, and I can solve by completing the square. So before we get into all this solving business, what we're going to do is we're going to quickly review perfect squares. So x plus 3 quantity squared, again, this is what we call the cringe problem. X plus 3 times x plus 3. And again, I'm going to do the area method to multiply this out, whichever way you multiply it. If you use split or stack, go ahead and do that. And you get that it's equal to x squared plus 6x plus 9. This is what's called a perfect square trinomial. And this is what we are looking at making today. Now, when we do this, there is a formula. And we use b over 2 quantity squared. Why over 2? Because if I think about it, there are 2 of those middle terms when I'm multiplying it out. And so if we have the first part, so if we had x squared plus 6x, saying what is that perfect c value? Well, we know that that middle term, there's actually 2 identical terms there, so we divide by 2 and then square it. So this formula right here, we're going to use quite a bit. So find the missing term to make x squared plus 8x plus blank into a trinomial square. So you're going to take your b term, divide it by 2. So 8 divided by 2 is 4. Squared is 16. So 16 goes on that missing line. So x squared plus 8x plus 16 is a perfect square trinomial. So find the value to complete the square and then write it in factored form. So the first part, find the perfect c. So to fill in the square, you're going to hear me refer to this as the perfect c value. So again, 10 divided by 2 squared would be 5. Squared is 25. So 25 is going to go on the line. Now, it says then write it in factored form. Well, we know it's going to be something quantity squared. We start with what is our variable? And then what did we square to get 25? Well, this was positive 5. So it's going to be x plus 5 quantity squared. I'm going to do the one below here. So we have a negative here. So like negative 12, we're going to do negative 12 divided by 2 squared, which is negative 6 squared. Again, a negative number squared is still positive. Your c value, your perfect c, will always be a positive number. Now, when we go to do the factoring, again, we know it's something quantity squared. Again, my variable is x. What did I square? I go to that point right there. Well, I squared negative 6. So minus 6. The sign of b and the sign in my final factored answer will always be the same. So if b is negative, I'm going to have a minus in my factored answer. If b is positive, then it's positive in my factored answer, as we saw here with the first example. I would like you to pause the video and try each of the next 2 on your own. Alright, so the top one you should have had 4 over 2, which is 2 squared is 4, so 4 is your perfect c. And when I factor it, again, my variable is x, b was positive, and 2 was the number that I squared. On the bottom, we had negative 8 divided by 2 is negative 4. Squared is positive 16, so our perfect c is 16. And when I factored, I have x minus, b was negative, so it's minus inside, and the number we squared was 4, so x minus 4 quantity squared. The reason we do this is part of solving by completing the square is we have to make a perfect square. Now, the completing the square, it is a process. I'm going to walk through the first example and then I will read through all of the steps. So those of you that are actually listening to the audio, I would recommend writing down these steps and then I will walk through another one talking about each of the steps as we go. All right, so the first thing, we look at this C value. Is this a perfect C? No. If you think about, there's the yo baby, yo baby, yo, if you ain't a comet, you gots to go chant. Very similar. If this isn't the perfect C, which spoiler alert, it never will be, it gots to go. So we're going to move it to the other side. And we are going to leave a blank in its place. And since we subtracted 23, we are going to subtract 23 over. Now, what we are going to do is, now that we've moved that non-perfect C out of the way, we are going to make the left side into a perfect square. So what we were just doing on the previous slide, where you go b over 2 quantity squared, so you get 10 divided by 2 is 5, squared is 25. So we are going to add 25 to both sides. Again, to maintain equality, what you do to one side, you have to do to the other. So if we're adding 25 to the left, we have to add 25 to the right. Hence why I put plus blank on both sides. All right, on the right side, we are actually going to add. So negative 23 plus 25 would be 2. On this left side, we are going to factor. Now, we know we've made a perfect square. So we are going to factor just like we did on the previous slide. Our variable is x, b is positive, and what is the number we squared to get 25? Well, that was 5. So this number here is what's going to go there every single time. Now, once we've got to this point, x plus 5 quantity squared equals 2. This is what we were doing back in section 2. So there's nothing on the outside, so we're going to square root both sides, and we get x plus 5 equals plus or minus the square root of 2. Subtract the 5 to get it x by itself, and we get x equals negative 5 plus or minus the square root of 2. And then our last step, again, that is our exact answer. We are going to get our approximate answer, so you're going to go negative 5 minus the square root of 2. You get negative 6.41. And again, to get the larger answer, you're always going to add. So negative 5 plus the square root of 2, and we get negative 3.59. So those are the two solutions. Those of you that are actually listening to the audio, again, I would write this in the margin. Step 1 is move the non-perfect square. Step 2, find and add the perfect C to both sides. Again, step 2 is find and add the perfect C to both sides. Step 3, factor the left side, simplify the right side. Again, step 3, factor the left side, simplify the right side. And then step 4 is solve like we did in section 8.2. So again, 4, solve like we did in section 8.2. So again, I'm going to walk you through a whole problem. If you feel like you can do this on your own, feel free to pause the video and try doing it, but I'm going to walk through step by step how to do this again. So again, step 1, move the non-perfect C. So we are going to add the 7 to both sides to get rid of it. So x squared plus 6x plus blank equals 0 plus 7 would be 7 plus blank. So again, that is step 1. Step 2, find and add the perfect C. So we're going to go 6 over 2 squared equals 3 squared equals 9. So we're going to add that to both sides. So we add that perfect C to both sides. Step 3 was factor the left side. So on the left side here we had x, b was positive, And again, the number that we squared was 3, so x plus 3 quantity squared. And then on the right side, we're going to simplify. So 7 plus 9, that's 16. This is the completing the square part, right there. Those first 3 steps, that's what makes it completing the square. From here, the solving part, this is just like what we did in section 8.2. So we're going to square root both sides. So you get x plus 3 equals plus or minus the square root of 16. Subtract the 3 so that x is by itself, and you get x equals negative 3 plus or minus the square root of 16. And then again, we are going to calculate this, and we get that x equals negative 7 and positive 1. Again, when we have a perfect square, in this case 16, we will actually get integer solutions. If we don't have a perfect square, we will get irrational solutions like we did on the left problem. We will go through a few of these in class, but we are going to move on to the last slide here. Completing the square is also how to convert from standard form to vertex form. So in chapter 7, we talked about graphing, and when we talked about vertex form, we talked about how you multiply the equation out to get it to standard form. And we also mentioned that when you are factoring, you're actually converting from standard form to intercept form. And I intentionally didn't say anything about vertex form because I knew we weren't going to get to it till this chapter. But now we are. The process is very similar. This is not a perfect square, so we're going to move it. What's different is now we don't have a number over here. So we can't subtract 15 from y. So we're going to go, it's y minus 15 plus blank equals x squared plus 8x plus blank. So we're still going to do the plus blank. The only thing is, instead of having a number like 0 to start with, we have y. And it's not that huge of a deal. All right, again, step 2, we're going to make a perfect square. So 8 over 2, quantity squared equals 4 squared, which equals 16. So we're going to add 16 to both sides. Our sides happen to be flipped right now, but that doesn't really change anything. We are still going to be factoring this perfect square side. So we had our variable as x, b was positive, the number we squared was 4, so x plus 4 quantity squared. On the left side here, we've got y, and then negative 15 plus 16 would be plus 1. Our last step, subtract the value over so that k is on the correct side. And so we get x plus 4 quantity squared minus 1. And that's our answer. That is converting to vertex form. So no solving, no final, decimals or anything like that. This is just our final answer. So the process is the same for the next one. So I'd like you to pause the video and try the next one on your own. So again, we subtract that non-perfect c to begin. So you're going to have y minus 5 plus, and again, you're going to add the blank because we're going to add that perfect c to both sides. So y minus 5 plus blank equals, and on the left side, we got x squared minus 6x plus blank. So we take our b value, which is negative 6, divide by 2, so we get negative 3, and square it. We get positive 9, so we add 9 to both sides. Negative 5 plus 9 is 4, so we have y plus 4 on the left. Again, when I do my factoring, my variable was x. B was negative, so it's minus inside. And again, 3 was the number that we squared, or you could say it's negative 3, so it's minus 3 on the inside. Quantity squared, and then add whatever, or add or subtract whatever number is by y, so that y is by itself. So y equals x minus 3, quantity squared, minus 4. We will do a couple of these in class as well. So if you have any questions, make sure you're ready to ask. Otherwise, have a great day, everyone.